Hello students, welcome to our PHENOLS online classes. So in the previous video, we have discussed up to the esterification, that is reactions involving cleavage of OH bond. So that concept is completed. Clear? And second one is reactions involving cleavage of carbon and oxygen bond, CO bond, carbon and oxygen bond. This is the second one. I already mentioned the reactions of the alcohols are divided into two types. One is the reactions involving the cleavage of CH bond and OH bond, and another one is the second one, reactions involving cleavage of CO bond. Clear? The reactions involving the cleavage of CO bond is mainly shown by alcohols. Mainly shown by which one here? Alcohols. And the phenols, and with only zinc, it will show this type of reaction. Yeah, so that's why. And the reactions involving the cleavage of CO bond with the phenol is, we will discuss only with the zinc, but and alcohols are quite exhibit this type of cleavages. Yeah? And what are the reactions? First we will discuss the reactions which comes under the cleavage of CO bond. Yeah? And first one is here reaction with the hydrogen halides. The first one is reaction with hydrogen halides, or you can simply say halogen acids also. Yes, this we have already discussed. Halogen acids, we have already discussed this one in the haloalkanes and haloanes. Clear? And the first one here in this case, and I will write hydrogen halides. Hydrogen halides means you already know. One is HI and another one is HBr and HCl. This is clear. And if you know reactivity R, that I will not discuss detail here. We have already discussed it in the haloalkanes and haloanes. Clear? What is the reactivity order of the hydrogen halides or halogen acids are? HI is more reactive than the HBr than the HCl. Clear? And next one. And it has to be reactive with which one? Alcohols. What is the reactivity order of the alcohols here? Reactivity order, if you take reactivity order of alcohols here. Reactivity order of alcohols. Clear? So tertiary alcohols are more reactive than the secondary alcohols. And this one is more reactive than primary alcohols. So this is the concept. Clear? So reaction to the halogen acids and reactivity order of the halogen acids which involved in this reaction is HI is more reactive than HBr and HCl. Now what is the reactivity order means? Tertiary alcohols more reactive than the secondary alcohol than primary alcohols. First I will write reaction with HCl. First one I will write here reaction with HCl. First one I will do, I will take the primary alcohols. Take the primary alcohol, and what is the primary alcohol? Simply I will write CH3 and CH2 OH. This is the primary alcohol. Ethyl alcohol, OH is attached to CH group, so it is a primary alcohol. And first I treat this one with the HCl. Clear? You know primary alcohol is less reactive and HCl is also less reactive, so that's why the reaction needs here some catalyst. Why? Because both are very less reactive. So to make it happen, the reaction it takes much time. So to reduce that time, what we have to use here, we have to use one catalyst, that is anhydrous zinc chloride, ZnCl. Anhydrous zinc chloride. Clear? Then the reaction become fast. then what will happen, you see? And here H and here OH will be removed. See which bond is breaking here? Carbon and oxygen bond is breaking. So that's why here this is reaction involving the cleavage of CO bond. One example. Clear? So now what you will get the compound CH3, CH2, Cl plus what you will get here? H2. And I already mentioned in the previous haloalkanes and haloaridine chapter, the mixture of concentrate HCl and anhydrous zinc chloride is called as a Lucas reagent. Is called as a which one? Lucas reagent. So now second one, this is HCl, the mixture of HCl plus anhydrous ZnCl2 is called as a Lucas reagent. Lucas reagent. Very, very important. This is you have to remember. Clear? And in the same way, secondary alcohol. Secondary alcohol means I will write here CH3 and OH. Shall I write this is the secondary alcohol? Yes. And it is a HCl. This is a primary alcohol, and this is secondary alcohol. Clear? Secondary alcohol. And same with the anhydrous zinc chloride as a catalyst. Clear? Now what happened? Same, you will get the secondary alkyl halides. This is secondary alcohol, so that's why you will get the secondary alkyl halide. CHCl plus what you will get here? H2O molecule will be removed. In the same way, this is the primary and this is secondary. And last one is which one? Tertiary. You know what is the tertiary alcohol? I will take here. This is the one, and here OH, tertiary alcohol plus HCl. Clear? And we have already discussed tertiary alcohol. Here are the reactivity order. Tertiary alcohols are more reactive, so that's why, and they can easily react with the HCl even in absence of anhydrous zinc chloride. Catalyst is not required here. Even this reaction takes place very fast in absence of catalyst. So that's why we will consider this is we need not to require here, we need not to use and anhydrous ZnCl. If you use also, no problem. The reaction and takes place and somewhat fast. So that's why what you will get the compound? You will get the compound C and CH3 and CH3Cl plus what you will get here? H2O. Yeah, got the point here? So this is we will call as a reaction with the halogen halides. Reaction of the alcohols with halogen halides. See first one, and this is Lucas reagent. And this test is alcohol with the Lucas. They are reacting with which one? This is Lucas reagent. And if I also take here, this is also what it is, Lucas reagent. Primary alcohol, secondary alcohol, and tertiary alcohols are reacting with which one? Lucas reagent. And this is the very good method to distinguish between the primary, secondary, and tertiary alcohols. So why I am saying here, and primary alcohols if I take, and if I take here tertiary alcohol, I already mentioned tertiary alcohols react very fast. And how to do this, how to perform this test is, first you have to take the one beaker and add here alcohol. Here what it is? Alcohol. And this is the alcohol. And add after then here Lucas reagent. Yeah? And alcohols are dissolved in Lucas reagent, or you can simply say soluble in Lucas reagent. Clear? Now what happened here? Lucas reagent react with which one here? Now alcohols. When Lucas reagent is converted into reacted with alcohol, they are converted into alkyl halides, and these alkyl halides are immiscible in Lucas reagent and produces turbidity. Produces which one here? Turbidity. So that's why by forming this turbidity we can easily identify and which alcohol is more reactive towards with the Lucas reagent. And how means, and if you take here tertiary alcohols, and tertiary alcohols with the low-cost reagent. Low-cost reagent, and here turbidity will form immediately. Which one will form here? Turbidity. Turbidity form immediately. Immediately it forms. Turbidity it forms immediately. Means within the seconds, turbidity will form with the tertiary alcohols. Clear? And if it is secondary alcohols are there, take the secondary alcohols and treated this one with the low-cost reagent. LR I am writing. LR means what it is? Low-cost reagent. And here also alkyl halides with secondary alkyl halide will be formed. So the solution will be converted into turbidity, and here the turbidity, and it forms within 5 minutes. And turbidity forms, and here within 5 minutes. Immediately it forms, and it is a tertiary alcohols, and it takes 5 minutes time to form turbidity. Then that alcohol is a secondary alcohol. And if I take here primary alcohols, with the low-cost reagent at room temperature, we will not get any turbidity. Or you can say here turbidity will form after 1 hour. Clear? And here you can say no turbidity. You can say here no turbidity at room temperature. No turbidity at room temperature. So that by using this reaction, we can, by using with low-cost reagent, we can easily distinguish the which alcohol is a primary alcohol, secondary alcohol, and tertiary alcohol. Clear? So tertiary alcohol with the low-cost reagent, turbidity means they have given here 3 alcohols to you, and 1 low-cost reagent they have given. And they asked to identify which one is the tertiary alcohol. Then what you have to do? And 3 bakers are there, and take in 1 baker there is a tertiary alcohol, another baker secondary, and another baker primary. Add the low-cost reagent to the first baker. If you get the turbidity immediately, then it is a tertiary alcohol. And second, if you add in the second baker, and turbidity it is coming slowly, means it takes time, and it forms within 5 minutes, it is a secondary alcohol. Then no turbidity is forming at room temperature, then it is a primary alcohol. This is the reaction of alcohols with the hydrogen halides, specifically with which one? HC. Next, second one is reaction with phosphorus halides. Alcohols reaction with phosphorus halides. Clear? And this also we have already discussed in the haloalkanes and halohalides. That's why we are saying, and whenever I mentioned when we discussed about the haloalkanes and the halohalides, you have to read the chapter very perfectly, because the same reactions will come in the next chapter. So you see, alcohol, if you prepare very clearly alcohol, it helps in the aldehydes, ketones and carboxylic acid. Link is there for every chapter. So that's why you must very perfect with the previous chapters. Clear? So now reaction with phosphorus halides. You know, alcohol reacted with the phosphorus halides means we have 2 types of phosphorus halides. One is phosphorus trihalides and another one is phosphorus pentahalides. Clear? And first I will write here phosphorus trihalide. X can be here chlorine and bromine, and take this one heat. I already clearly mentioned, whenever alcohol reacts with the phosphorus trihalides, you have to take here 3 moles of alcohols. You have to take how many moles of alcohol? 3 mole, and here it is a 1 mole. Then what happens, you see? And then 3 halides, 3 OH groups are replaced by halides. Then you will get the 3 base here, 3 moles of alkyl halide plus, and P and 3 OH groups are there, that we can write here H3PO3 or simply POH thrice. This is what it is, POH thrice. Yeah. So this is the reaction with what it is, PS. I have mentioned here chlorine and bromine, not the iodine, because and phosphorus triiodide is a, it is very unstable compound. So that's why you have to prepare the phosphorus iodide itself in the reaction only. That we will call as an in situ preparation. Clear? So now, simple example I will write here. CH3 and CH2OH, and take the 3 molecules, and here PCl3. Then what the compound you will get here? And 3 moles of CH3, CH2 and Cl plus, and what you will get here? H3PO. Clear? When bromide is there, then bromide, same reaction. But when iodide is there, they will give in this way, OH, and in the on the arrow they will give red phosphorus and iodine. Red phosphorus and iodine. You have to prepare red phosphorus and iodine. You will get again here PI3 only. But PI3 directly we cannot take. Why? Because PI3 is a very unstable compound, and before adding it to the reaction, it may decompose. So that's why. And then take the mixture and add the red phosphorus and iodine. And the red iodine will react with the red phosphorus, and it forms PI3. The PI3 immediately react with alcohol, and it forms, and you know, 3 moles of CH3, CH2I plus what you will get? H3PO. Yeah. And in the same, this is phosphorus trihalide. You have to take now phosphorus pentahalide. Now this is the first one, reaction with phosphorus trihalide. And next one is here with phosphorus pentahalide. Take the ROH and here PCl5. Take the ROH and PCl5. Then what happened here? I already said, in this reaction, 1 mole alcohol react with 1 mole PCl5 only. Then what happened? 1 OH is replaced by chlorine. Then you will get the RCl, alkyl halide. And another one is 1 H and 1 Cl will be removed as a HCl plus. And what is there? P and O, 3 chlorine atoms are there. You will get POCl3. And here phosphorus oxychloride. You will call this is phosphorus oxychloride. Here, same. If I take one example here, C2H5OH plus what it is? PCl5. Then what the compound will get? Ethyl alcohol, and you will get the ethyl chloride. 1 chlorine atom will be there, and 1 H and 1 Cl will be removed as a HCl and plus POCl. Okay? So sometimes what they will ask, when our alcohol reacts with the phosphorus trihalides, and along with the alkyl halide, what is the product you will get? Clear? So you will get the phosphorus. This is phosphorus acid. This is what we will call phosphorus acid. Phosphorus acid. Yeah. And when alcohol react with the PCl5 along with the alkyl halide, you will get the phosphorus oxychloride. Those are the products. Sometimes they may ask in this way also. And the next one is reaction with SOCl2. This is also we have discussed. Reaction with SOCl2, thionyl chloride. What is the this one? SOCl2 thionyl chloride. This is also we have discussed in the preparation of alkyl halides. We used all these reactions. Reaction with what here? Thionyl chloride. And this process method also we have discussed. What is this method? Dehydration method. What do we call this method? Dehydration method. Preparation of alkyl halides from the alcohol by treating the thionyl chloride. Yeah? So you know alcohol, ROH. The general formula of alcohol is ROH, and they treated this one with the SOCl2 thionyl chloride. Yeah? Then what happens? 1 OH will be replaced by the substituted by the chlorine. Then you will get the alkyl halide, alkyl chloride. And here 1 H and 1 Cl will be removed as a HCl, and 1 O left and SO left it will be removed as a SO. And we have already mentioned, and the reaction with SOCl method we will call it as a Dehydration method. And this is the very good, or you can say the convenient method to prepare the alkyl halides from the alcohol. Why? Because means the products which are formed in this reaction is products are SO2 and HCl. Both are which one? Gases. So that's why they can easily escape from the reaction mixture, so you will get the very pure alkyl halides. So that's why to prepare the alkyl halides from the alcohol, and this method we will treat the alcohol with the SOCl2. So that's why this is the very convenient method to prepare the alkyl halide. You will get the very pure alkyl halide. So that's why we prefer this method to prepare the alkyl halides. And take the example C2H5 OH plus what it is SOCl2. Then what the compound you will get C2H5 Cl plus SO2 plus what you will get here HCl. So this is the reaction with what it is SOCl. Clear? And the next one is there here dehydration. Third one is which one? Dehydration. This is second one, and here third and the fourth one dehydration. Dehydration. Clear? So what is meant by dehydration? You know, removal of water. Removal of water we will consider it as a dehydration. Clear? You know that alcohols are involved in the dehydration to form alkenes. Clear? So how they are converted, alcohols are converted into alkene by the dehydration process. Clear? You know, alcohols when they are involved in the dehydration reaction and forms the alkenes in presence of dehydrating agents. We have to use which agents here? Dehydrating agents. What are those? We will discuss here. Suppose, and the general formula I will write here. This is a H, and you know, and this is a OH, alcohol. I have taken alcohol here. If you want, you can take ethyl alcohol and H and H and H. This is ethyl alcohol. Now I have to use here dehydrating agents. You have to use here dehydrating agents. You have to use dehydrating agent and just heat it. Then what the compound you will get? Elimination reaction. Dehydration. Clear? And the OH and H from the adjacent carbons only. And the removed, and two groups are removed here. Single bond is converted into which one here? Single bond is converted into double bond. Single bond is converted into which one here? Double bond. Clear? And what are the dehydrating agents we will use commonly? And the dehydrating agents are concentrated H2SO4, or you can say concentrated H3PO4 and anhydrous zinc chloride, and can also be a Al2. These are some very main important dehydrating agents. Clear? And take the compound alcohol in the presence of concentrated H2SO4 and just heat it. Heat is required. Just heat it, then you will get the water molecule will be removed, and you will get the compound is which one here? Alkene. Means you can say sometimes when alcohols involved in the dehydration, then what is the product means? You will get the product is alkene. Now just now we have discussed about the dehydrating agents. We have some dehydrating agents. Now how primary, secondary and tertiary alcohols involved in the dehydration reactions. Clear? So now if I take here first primary alcohol, I will take CH3, CH2OH. This is a which alcohol? Primary alcohol. Ethanol, we will call this is a ethanol. Primary alcohol. When it is heated with concentrate H2SO4, means acidic medium, and around 443 Kelvin. Around what it is? 443 Kelvin. Then what the compound you will get? From here, hydrogen from the beta carbon. OH attached carbon, alpha carbon, attached carbon, beta carbon. So, and beta hydrogen and OH will be removed, and you will get the compound is CH2 double bond CH2 plus what you will get here? H2. Okay? We have to use here concentrate H2SO4. You can simply write instead of H plus concentrate H2SO4. Very powerful dehydrating agent. Okay? But if you take the secondary and tertiary alcohols involved in the dehydration reactions under very mild conditions. We need not to maintain very drastic conditions. Like you see, we have used here very strong dehydrating agent, and also we maintain high temperature. But if you go for secondary alcohol, and the secondary and tertiary alcohols involved in the dehydration under mild conditions, means you can take here 85% of H3PO4 and you can maintain the temperature here 440 Kelvin. Then what happens, you see, and you know, and one H and one OH will be removed. H will be removed from the addition carbon, H and OH. You will get the double bond here. Suppose this is, if I write H here, then what will happen? H and OH will be removed, and between these two carbon double bond will form. So what the compound you will get? CH3, CH double bond, CH2 plus what it is? H2O. This is what it is, alkene. And here also you are getting alkene. In the same way, if you go for tertiary alcohols, CH3 and CH3OH. Yeah? And for this one, very mild conditions are required. And you can say simply, and 25% or around 20%, you can say 20% H3PO4, and temperature also very less, and 358 Kelvin is required. Then what happened here? Same, shall I write here? And the hydrogen addition carbon, one hydrogen and OH carbon. This 1, 2 carbon. Here, OH attached carbon, addition carbon, hydrogen and OH. Then what the compound you will get? CH3 and C double bond CH2, and you will get the compound is here CH3 plus H2. Okay? And by seeing this reaction, we can easily say and the reactivity of alcohol in the dehydration. Which alcohol involves in the dehydration very fast? Because you see, for primary alcohols, we have to use very drastic condition, very strong oxidizing dehydrating agent. But here, it is also strong, but with how much percent? 20%, and temperature also. And we come down here, temperature also we are maintaining less. So that's why tertiary alcohols involved in the dehydration reaction very fast compared to the secondary alcohol and primary alcohol. Now you see, in this case also, which bond is breaking here? C, OH bond is O bond is breaking or not? CO bond is breaking. So reactivity order of alcohols in dehydration. Yeah. So what is which alcohol react very involved in the dehydration? Tertiary alcohols are more reactive compared to the secondary alcohols, and the last one is primary alcohols. So this is reactivity order of the alcohols here, alcohols in the dehydration reaction. Now, and very important question is there for the PU examination, and here mechanism of ethanol to ethene, means how this dehydration reaction takes place. And the dehydration reaction involves how many steps, that we have to discuss. Very important for the PU examination also. What the question they will ask is, and write the mechanism involved in the conversion of ethanol to ethene. Conversion of ethanol to ethene means this is ethanol means what is the compound? CH3, CH2, OH, and you know we have to maintain H plus and E. Then what the compound you will get? CH2 and CH2 plus what you will get? H2. What is this compound? It is a ethanol, and here what is this alkene? Or you can simply say ethene. Clear? The mechanism of dehydration of alcohols involves 3 steps. Involves how many steps here? 3 steps. And here, step 1. What is the step 1? This is mechanism. You have to write here mechanism of this alcohol. Okay? Alcohols to alkene. Step 1. Step 1 is here protonation of alcohol. What is the step 1 here? Protonation of alcohol. Protonation of alcohol means, and this Dehydrating agent we use here. Which one is the dehydrating agent? Concentrated H2SO4. Concentrated H2SO4 means it is an acid. It produces H plus, and this H plus will be added to alcohol that we will call as a protonation. Proton is added, so that's why protonation. So first step is protonation of alcohol. What is that? CH3 and CH2. You know, OH and plus H plus. Okay. Then what happened, you know? And here, lone pair of electrons are there on the oxygen. Oxygen is more reactive, means oxygen is electron rich and H plus is electron deficient. So it donates a pair of electrons to electron deficient, that is H plus, and make a bond. Then what the compound you will get here? CH3, CH2, and here OH and OH. Oxygen donates electrons, so it is losing electrons, acquires positive charge. That is the first step. We will call it as protonation of alcohols. Okay? And next one, step 2. Next one, step 2. First one is protonation of alcohol. Step 2 is formation of carbocation. What is the step 2 here? Formation of carbocation. See the intermediate, what is intermediate in the dehydration of alcohols? Very important. Carbocation is the intermediate in the dehydration of alcohols. Now, what is we got here? Protonated alcohol, and I will write this protonated alcohols here, and H and H, and this is positive charge. You already know. Oxygen having the positive charge, highly electronegative atom having the positive charge means it is unstable. So what it will do? It gain the electrons from this bond. Means carbon is losing electron, oxygen is gaining electron. Which one is losing electron here? Carbon is losing electron, oxygen is gaining electron. Losing electron means which charge it acquires? Positive charge. So carbon acquires the positive charge. Oxygen is gaining electron. Oxygen acquires the negative charge. Already positive charge is there. Charge will be neutralized. Then we will get the H2. Simple one. Yeah. And step 3. And step 3. So if you see the step 3, then what happens? Deprotonation. 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 Means deprotonation means what? Protonation, proton. Proton, you have D means remove. Removal of proton. So what it is there here? Carbocation. This is the carbocation. On the carbon positive charge is there. It is carbocation. And now deprotonation here. CH and here H, and I am writing the same, and H and positive charge. I will write here positive charge and H and H. This is only I am writing the same. So deprotonation, third step is deprotonation. So I have written the carbocation here in the form of hydrogens. So here carbon is having the positive charge, so that's why. And what happened? To neutralize this charge, one of these CH bond shift here. Then it becomes a double bond, and it is double bond comes, and this carbon will have the 4 bonds, so it will be removed as a H plus. So that's why what happened, you see, you will get the H, a double bond, and the CH, and here also H, then you will get the which one here? H plus. Yeah. So this is the means, you know, if it is removed as a H plus, carbon gets the negative charge, negative and positive charge on the adjacent molecule, bond formation takes place. So that is why, and you are getting here finally alkene. So you know, dehydration of alcohol. What is the intermediate here is carbocation. So that's why you see here. And what is the reactivity of alcohol in the dehydration means I have mentioned tertiary, secondary and primary alcohol. Because you know that, and tertiary alcohols involved, then it gives the intermediate tertiary carbocation. And secondary involves means secondary carbocation, primary carbocation. Which carbocation is more stable? You already know tertiary carbocation is more stable, so that's why tertiary alcohols involved in the dehydration reaction very fast. And very important for the PU examination, we have to practice this mechanism, conversion of alcohols to alkene, ethanol to ether. So next one, and dehydration of alcohols we have already completed. So now next concept is oxidation of alcohols. Okay, you know Oxidation of alcohols involves in the formation of carbon-oxygen double bond by breaking of CH bond and OH bond. Yeah, simply you see. Oxidation of alcohols. Previous I already mentioned AAA method. Alcohols oxidation. You will get the primary alcohols mainly. Oxidation, aldehydes. Aldehyde oxidation, you will get the carboxylic acids. Means whenever we take the alcohol, you know alcohol means this is H and this is OH. This is alcohol, COH. I have taken. Yeah. Now, whenever alcohols involved in the oxidation process, then what happened? You will get the product is C double bond O, means carbonyl compound. Means what happened? You see, oxidation of alcohols involves in the formation of carbon-oxygen double bond by breaking CH bond and OH bond. By breaking which one? CH bond and OH bond. You simply see and remove the hydrogen from the carbon and oxygen, hydrogen from the oxygen. Remove these two. That is breaking CH bond and OH bond. Then what you are getting here? C double bond O. And this reaction, oxidation of alcohols, conversion of alcohols into carbonyl compounds, can also be called as dehydration. It is called as, this reaction can also called as dehydrogenation. Dehydrogenation. Okay? Means you see, not dehydration, dehydrogenation. Hydrogen means you have to remove the hydrogen means H2. D means remove. We are removing the H and H. What you are removing here? H2. Removing it. So that's why this oxidation of alcohols can also be called as a dehydrogenation. Yeah. And here, and different alcohols gives and different products when they involved in the oxidation. Yeah. Now you see. And first I will write here, whenever primary alcohols are involved in the oxidation. Primary alcohols are involved in the oxidation. First it will be oxidized to aldehyde. And further under oxidation, it will be converted into acids. Yeah, I already mentioned. Alcohol, primary alcohols are oxidized to aldehyde, aldehydes are oxidized to acid. And here, this carbon, how many carbon atoms are there? Acid also will have the same number of carbon atoms. Suppose here 2 carbon atoms are there, and here also 2 carbon atoms in the acid. And the second one, if you take the tertiary alcohols, if you take, and here oxidation. Primary alcohols are oxidized to aldehyde, secondary alcohols are oxidized to ketone. And further oxidation, you will get acids. But if you compare here carbon atoms and acid will have the less number of carbon atoms, than original alcohol. This is important. Clear? And third one. Now which alcohols undergoes oxidation? And tertiary alcohols. Tertiary alcohols actually do not undergo oxidation because you know for oxidation and OH attached carbon should have at least one hydrogen. But here you see alcohol, tertiary alcohol, if you take CH3 and CH3OH. Here H will be removed here, but carbon doesn't have hydrogen, so that's why. And oxidation means, and it will not undergo, tertiary alcohols will not undergo oxidation. But in some conditions, first they are converted into alkene. I will say what are those. And further oxidation we will get ketone plus acids. Ketone plus what it is? Acids. Same here also, less number of carbon means atoms than the original alcohol. But important is these two. This is tertiary alcohols will not undergo oxidation, will not involve in the oxidation because it doesn't have the carbon hydrogen. So I will write here one by one reactions. Clear? And first one I will write primary alcohol. I will write here RCH2OH. If it undergo oxidation, then what we will get? We will get the RCHO aldehyde. And if you take here further oxidation, and this will be converted into acid. Yeah? Means if you use the strong oxidizing agent, then primary alcohols are directly converted into acids. Directly converted into acids. What are those strong oxidizing agents? Means strong oxidizing agents. What are the strong oxidizing agents? Means, and here we can simply write KMnO4, potassium permanganate in the alkali medium, neutral medium, or acidic medium. And the second one is potassium dichromate, K2Cr2O7 in acidic medium, dilute H2SO4, and sometimes it can be HNO3 also. Clear? If you use any one of these oxidizing agents, powerful oxidizing agents, you can say strong oxidizing agents, then alcohols are directly converted into which one? Acids. It won't be, this reaction will not be stopped at aldehyde stage. Directly alcohols are converted into acids. But if you use mild oxidizing agents, then alcohols are converted into aldehydes. Means the reaction stops at the aldehyde stage only. And what are those mild oxidizing agents? You can use some oxidizing agents, and by using that oxidizing agents, alcohols are oxidized to only aldehydes. Means if you take here RCH2OH and do the oxidation and convert it into RCH. So what are those oxidizing agents? Here oxidizing agents are Collins reagent. What it is there in the answer book only. Collins reagent, that is we will consider as a chromium dioxide and pyridine complex C2H5N. This is clear. And another one is very important is PCC. This is mainly we will use PCC. What is the PCC? Means pyridinium chlorochromate. Pyridinium chlorochromate. That what it is? It is a complex of pyridinium C5H5NH plus CrO3Cl minus. This is the pyridinium complex, and it will also will not affect the double bonds in the alcohols. And the next one is here PDC. PDC means pyridinium dichromate. Pyridinium, what it is here? Dichromate. What is the formula means here? Pyridinium dichromate means C5H5N twice plus and Cr2O7 2 minus. This is potassium dichromate K2Cr2O7. Pyridinium dichromate C5H5NH plus you can write here Cr2O7 2 minus. Here 2 plus on the bracket we have write positive 2 plus and 2 minus. And these are the oxidizing agents which convert the primary alcohols into aldehyde. Further oxidation will not take place. Suppose simple example, I will write here suppose I will write CH3 and CH2OH. If I use here PCC, or you can use here CrO3 in dry solvents. Like CH2Cl2, then this compound is converted into CH2 and CH2. Yeah? It stops where? At aldehyde stage only. And if I take suppose CH3, CH double bond, and here CH and CH2OH, and directly you can write here PCC. PCC is very good oxidizing method which converts the primary alcohols into aldehyde without affecting the double bond. Then what the compound will get? CH3, CH and CH and CH. So this is how primary alcohols are converted into aldehyde. If you you take the secondary alcohol, you will get the ketones. If you take the secondary alcohol and suppose if I write CH3, CHOH and CH3. If I write here CrO3 in the CH2Cl dry medium. This is secondary alcohol. Secondary alcohols are converted into which one here? Ketones. CH3, C double bond O, and here CH. So this is about dry alcohols. See here, just now I have mentioned oxidation with not strong oxidizing agents. These are somewhat mild oxidizing agents, we can say. So whenever oxidizing agents like PCC or you can say CrO3 here, and primary alcohols are oxidized to aldehydes. Further oxidation will not take place because it is not strong oxidizing agent. Secondary alcohols are converted to ketones, and tertiary alcohols will not involved in oxidation reaction because here there is no H is there to remove the hydrogen. So this is now, and first I mentioned here primary alcohols. Primary alcohols, if I take the strong oxidizing agent, primary alcohols are converted into aldehydes, and aldehydes are converted into acids with the same carbon atoms. Alcohol, original alcohol, and acid will have the same carbon atoms. I am talking about the strong oxidizing agent here. Suppose I will take this carbon CH3 and CH2OH. If I use potassium dichromate K2Cr2O7 and dilute H2SO4, then what the compound you will get? First it will be converted into aldehyde. CH3, CH2, C double bond OH. This is aldehyde, but it is a strong oxidizing agent, so that's why the reaction will not stop at aldehyde stage, and again further oxidation takes place, and with the same reagent, then it will be converted into acid. CH3 and CH2 double bond O is converted into COOH. Yeah. Now take this is for primary alcohols. This is for which alcohol? Primary alcohols. So if I take secondary alcohol, CH3, and I will take here CH3, H and OH. Same oxidizing agent, very strong oxidizing agent, and first it will be converted into ketones. CH3, CH3. Oh, sorry, I will take 4 compound, like I will write here CH2. CH2OH again. Sorry, it is again. I will write here OH, and this is CH2CH. This is secondary alcohol. Now what do you get? CH2CH3. Yeah, secondary alcohols are converted into ketones. Now, and strong oxidizing agent, further oxidation takes place. Yeah, further oxidation means now here what the means I already mentioned. Secondary alcohol, oxidation ketones, further oxidation acids. Now here, which acid has to form? Suppose this bond break, then you will get the formic acid, and another one you will get the 3 carbon acids here. But which bond has to be broken? This one or this one? That decided by the here one rule. That rule we will call as Popov's rule. Clear? So what is this rule? According to this rule, always the carbonyl group, the C double bond O group remains attached to smaller alkyl group. So what is that one? According to this rule, and C double bond O group remains attached to smaller alkyl group. This is Popov's. Clear? So what it is see now? To the CO, one is which group? Methyl group, and another one is which group? Ethyl group. So always CO is attached to CH3 only. So it will be always remain. So that's why the bond has to break here. If this bond breaks, it will be converted into acid, and this one also converted into acid. So CH3, and COOH plus. Here also CH3 is converted into acid. CH3COOH. So here how many carbon atoms are there? You see in the original alcohol 4, but here in the acids we have the 2 carbons. So that's why, and the acid will have the less number of carbon atoms than the secondary alcohol. In the same way, if you take the tertiary alcohols CH3 and CH3 OH. First of all, it will not undergo oxidation. First of all, what it is, and in the H plus heat if you do, then what you will get here? Dehydration, means CH3 now CH2, and here there will be a CH2. Okay? First, because tertiary alcohols will not involved in the, means they will not oxidize. They will not involved in the oxidation. So first what we did here, H plus and heat you did, then you will get the alkene. Now you do the oxidation Cr2O7 and H2SO4. Then what happened here? This bond will break, where the double bond will break, and you will get the ketone, that is CH3 and C double bond O CH3 plus. This will be converted to acid formate acid. That's why I mentioned here. Here also you see. Primary alcohol, you will get the acid with the same number of carbon atoms. Secondary alcohol, strong oxidizing agent, you will get the acid but less number of carbon atoms than the original alcohol. And the tertiary alcohol, if you take, first you have to do the dehydration, after then do the oxidation, then you will get the ketones and acids at the products. So oxidation we have completed. You already know tertiary alcohols will not undergo in oxidation. Clear? So next one is an oxidation with heated copper. Clear? And the primary alcohols and secondary alcohols are tertiary alcohols, and the vapors of alcohols are passed over heated copper at around 300 Kelvin temperature, 300 degree centigrade, or you can simply say 573 Kelvin. Then same primary alcohols are oxidized to aldehydes, and secondary alcohols are oxidized to ketones. But here tertiary alcohols will not undergo oxidation, but and here removal of water, means dehydrogenation takes place. So what are those? First I will write here primary alcohols, CH3 CH2 OH. This is which alcohol here? Primary alcohols. Okay? So now what I will do here, copper, heated copper, and 573 Kelvin, or you can simply say 300 degrees centigrade. Then alcohols are oxidized to which one? Aldehyde, CH. Okay? So what is removed here? You already know. One H here carbon and another H from the oxygen, and removed, and we got here aldehyde, dehydrogenation. Okay? And the next one, secondary alcohol you take CH3, and here H, CH3 OH. This is a which alcohol? Secondary alcohol, and same secondary alcohol copper and 573 Kelvin. 573 Kelvin, and then what the compound you will get here? You will get the compound is ketones, CH3CO. So here one H and H will be removed, and you are getting here ketones. Means here it is aldehyde. Here it is aldehyde, acetaldehyde, and here what is the product here? Ketone, acetone. This is acetone. Okay? And third one is CH3 and CH3OH, tertiary alcohol. Tertiary alcohols involved in the oxidation with very strong oxidizing agents only. With mild oxidizing agents, tertiary alcohol will not undergo any oxidation. So that's why if you heat this one with the copper at 573 Kelvin, then here there is no hydrogen here to remove the H and OH to form the carbonyl compounds. So that's why what happened here, it involves in the dehydration. So what will be happened here? Water, because we are heating here temperature. At that temperature, oxidation, in mixture of oxidation, what happens here? Dehydration. H and OH will be removed. So that's why you will get one compound is here and CH2, CH3. What is the compound here? Alkene. Plus what you will get here? H2O. So that's why, and these two reactions means primary alcohol and secondary alcohol involved with when reacted with the copper and 573 Kelvin temperature. Which one here? This is oxidation due to which one? Dehydrogenation. Dehydrogenation takes place here. But here which one takes place here? Dehydration takes place. This is dehydration. Dehydration means what it is? Water molecule is removed. Dehydrogenation means which one is removed here? H2 molecules are removed. So this is about the reactions involving cleavage of CO. So till now we have discussed about the reactions of alcohols. Now next concept is reaction of phenols. Yeah. Now phenols means the mainly phenols involves in the electrophilic aromatic substitution. Means what does it mean? Electrophile substitution takes place at which one? Aromatic. Aromatic means what is benzene ring. Yeah. In phenol, the reaction that takes place on the aromatic ring is, electrophilic substitution. Yeah. So that is the meaning of electrophilic aromatic. And electrophile and substitution takes place on which ring? Benzene ring. So that's why if you see here, the OH group present on the benzene ring, the OH group present on the benzene ring, and it is the responsible for the electrophilic substitution reaction on benzene. Why? Because OH is a electron donating group. When the electron donating group is present on the benzene ring, it donates the electrons to benzene in a very large extent. So that's why benzene ring is get activated. So that's why benzene ring is get activated means it is involved in the benzene get activated means benzene is electron rich here. So that's why it involved in the electrophilic substitution reaction, because it is negative charge, means it is having electron rich. It will react with the electron deficient. Electron deficient species means what we will call electrophile status. Means I already mentioned previous, whenever the OH group is present on the benzene ring and it is an electron donating group, so electron donating groups are ortho and para directing groups. How means? Due to the resonance. You see, previously we have already discussed about the resonance structures here, and the lone pair of electrons, and it will come here, and this bond electrons will go, then you will get the compound is here, double bond, and oxygen gets the positive charge and this carbon gets the negative charge. Again, negative charge and double bond is separated by single bond, so again there will be a conjugation involved in the resonance. We have already written this, and again once again I am explaining. And here H, there will be negative charge, and here. So again they involved in the resonance, and you will get the compound is, so here, and double bond and H plus, negative charge, and here. So again conjugation, this bond will come here, this bond will go to the oxygen, and you will get the compound again here, phenol, and these are the resonance structures. If you see the resonance structures, the OH group on the benzene ring is giving electrons to benzene ring. So that's why on the benzene ring, where the electron density will be high, at the ortho position. This is ortho position, this is para position. Again at which position? Ortho position. So that's why electrophilic substitution reactions takes place mainly at ortho and para positions. So these are the means why electrophilic substitution means why it is electron donating group case, ortho and para directing group means when they donate the electrons to benzene ring and benzene ring get activated and electron density will be very high at ortho and para position. So that's why electrophile attachment to the ortho and para position of the benzene ring. That is the next reactions are there. We will discuss next.